Wow, I'm really honored to be here. This week of all weeks. I have a feeling we could be friends. But I'm just really delighted to speak to you about my passion, my raison d'etre, which is the long-term well-being of our species and our planet. So we humans have lived here on Earth for 300,000 years, with some semblance of civilization for maybe 10,000 years. And we evolved from microorganisms that have been around for maybe 2.5 billion years. And life as we know it exists only here on the Earth. And it's spread throughout every biome, every niche on the planet. And it gave rise to humanity over a long struggle. And humanity has gone from a few scattered hunter-gatherers to 8 billion souls spread across the planet. We are a species of explorers, settlers, pioneers, and adventurers. And it's time for the next adventure. It's time for the greatest adventure. It's time for an adventure where the species launches into the cosmos for a truly infinite future. Space is the key to the constant betterment of our progeny, so that our children and their children and their children can have better lives than the ones that came before, as far as possible into the infinite future. Space is the only way that can happen, because space is the infinite frontier of the infinite resources that can support our exponentiating species. This is my most powerful personal, professional motivation. And so to get to come to talk to a wonderful group of people like you is really a thrill for me. So today's talk is on space mining and the future of space. So what I thought I'd do is spend some time telling you a little bit about how the space industry is changing, and wow, is it changing. And since it's about space mining, maybe you want to know a little bit about the resources of the solar system that are waiting for us. Because after all, if you get in an airliner and fly across the US on a clear night, not on a cloudy one, all the way across the continent, when you look down, you see lights. When you get in the space station, as one of my board members and former students has done, when you're up in space looking down at the Earth, there's the lights of humanity everywhere you go. But when you look out into the solar system, there aren't. But the resources out there outstrip the resources of the Earth tremendously. So I'll tell you a little bit about that. And then I'll tell you a little bit about our company, Transastra. So how is the space industry changing now? It's very exciting, and it's all made possible by the data in this plot. So by the way, there'll be a quiz on all these engineering plots afterwards. The students get an automatic pass, but everybody else. Okay, so on the vertical axis is the cost per kilogram. Kilogram is a unit of measure of mass that we engineers like better than pounds. If you want to understand why we like kilograms, watch the Saturday Night Live skit about George Washington. Has anyone seen that? But anyway, a kilogram is about 2.2 pounds. And this is the cost of getting 1 kilogram into low Earth orbit, just skimming over the surface of the Earth, depending on what year you're in. And what you can see is you have this yellow line that's descending very slowly. It wasn't improving for decades. And in fact, like the most expensive way ever to get into space was the space shuttle. It was a disaster. It slowed down America's advancement into space by decades. But so is tens of thousands of dollars per kilogram to get into space. And so when you put together all the ancillary hardware for people to go into space, it could be hundreds of millions of dollars for a person to travel into space. Just an absurdly high number. But then something really special happened in the early 00s, and that was the founding of SpaceX by a fellow that probably none of you have heard of, Elon Musk. And they started to build rockets like the private sector does things for the first time, where things get better over time. And what you see, and by the way, I was in the industry then. Everyone you talk to in the industry said, Elon's crazy, he will fail. I know a guy who bet against Elon. I saw him the other day, he's a greeter at Walmart. Don't bet against people like Elon Musk. Anyway, what you see is that at that point, the cost of space access started to drop precipitously from multiple tens of thousands of dollars a kilogram, less and less and less. It's already gone down by a factor of 10, and it's expected to go down by another factor of 10 or 100 in the coming years. And the importance of this cannot be overstated. Now, this is a slide that I actually made several years ago when I was the CTO of a company up in Silicon Valley. Show of hands, how many people know what a Falcon 9 is? So about a third. So Falcon 9 is the rocket that SpaceX uses every day to launch satellites into space. They launch about 100 to 150 Falcon 9 launches into space every year. By the way, that's more launches of one type of rocket into space than any other type of rocket in 1 year than any other type of rocket had ever done in the history of the space program. Just for context. Now, if you compare a Falcon 9, you've all seen pictures of the Falcon 9 on TV, to a 747, they both weigh about 1 million pounds. The numbers here are in kilograms, because I'm an engineer. And what you see is these two vehicles that each weigh 1 million pounds, and their fuel in both cases is kerosene. And they both carry about the same amount of kerosene, about 150 kilograms of 150,000 kilograms of kerosene. Kerosene is it's just like jet fuel that jet airplanes use. Now, it cost a couple of dollars a kilogram to fly on a 747 across the ocean. And when the Falcon 9 came out, from an engineering perspective, it looks like lots of other medium-class rockets. They're about that big, they carry about that much fuel. So why is it that rockets have always been so much more expensive than airplanes? Because we don't throw the airplane away at the end of every mission. And what Elon did was he led a company to create a truly reusable rocket that can come back down, and he has now had Falcon 9 first stages, which is most of the rocket, that have flown dozens of times into space. And that's the big cost savings. So that is ushering in a massive change in what happens in space. How many people have a Starlink terminal? Show of hands. One. My company has about 3 or 4 Starlink terminals. I was recently on a flight from Hawaii, where I was at a technical conference, to California, and United Airlines told me there would be no internet, so I switched to Hawaiian Air, and they had a Starlink terminal. So I was doing Zoom calls from my airliner. It's high-speed internet, better than what's in this building on an airplane because of Starlink. Now, for context, up until about 5 or 10 years ago, the total number of satellites that had ever been launched into space was about 3,000. In the last 6 months, SpaceX has launched about that many satellites into low Earth orbit with their Falcon 9. So this is the development of the Starlink satellite terminal, or the Starlink satellite network, over its history of about the last 5 years. This is a computer-generated graphic of how many Starlink satellites are in orbit. Starlink is the first example of a massive low Earth orbit constellation, And it's gone in the last few years from 0 to 6,000 satellites in orbit. And they're launching thousands more a year into space. And they have licenses to make their satellites bigger and launch at least 40,000 of them into space in the next few years. And that's just the first mega constellation. There are 5 other mega constellations under development being done by companies like Amazon, the Chinese, the Europeans, and various different other private ventures are doing this. So we expect 100,000 satellites in low Earth orbit within the next few years, up from the less than 5,000 that had been launched into space in the entire history of the space program, of the space age, up until 10 years ago. So things are changing, and what's driving it is cost. Now, this is a graphic that's been floating around on the internet recently. What you see in the lower left there is something called the Bechtel Tower. It's a new tower for the big expensive rocket that NASA is building. And the tower alone was originally bid to cost $400 million. And at latest estimate, it's supposed to cost $2.7 billion with a B dollars. This is for a tower that holds up a rocket. That's the military-industrial complex at work. On the right, you see a tower built in the Middle East, which is a building, and it's vastly bigger, put together in 5 years. Now, the Bechtel Tower that NASA's building has been under development for 13 years, and it's a copy of one that was made during the Apollo program. That's the military-industrial establishment showing their efficiency for you. In the middle is Mechzilla. Mechzilla is a tower that SpaceX built on its own for $200 million. It took a year, and it's way better than the other ones because it's also the biggest robotic arm in the world, and it can catch rockets out of the air. That's the difference in efficiency that we see. The difference that we see that's happening in space is that up until now, space has been dominated by the military-industrial establishment. Eisenhower warned us about it, but he didn't say what to do about it. In the year 2000, Jeff Bezos has asked me, why is it so expensive to get into space? Most people think it's because it's high energy and things could blow up. What I just showed you is the 747 carries the same amount of fuel as the Falcon 9. The energy levels are not higher. That's a myth. And the answer I came to him is the reason that space is expensive is because it's like, why is crack cocaine expensive? There's only a few idiots who want it and they're willing to pay anything to get it. And those idiots were the governments and multinational corporations that were willing to pay anything. And the space industrial complex, the military industrial complex, was willing to take all the money and do less and less for more and more until they can do almost nothing for everything. This slide is a slide that's been making its rounds on the internet recently, and I apologize for the small print, but I think you can read it. That compares the cost effectiveness of various different programs that NASA and some other agencies have been doing over the last few years. What their original cost estimates were and what their final cost estimates were. So for example, the JW Space Telescope that we've seen those nice pictures from, it's great. It was originally bid at $1 billion. It came in at $10 billion for a telescope. Mars Sample Return, JPL, where I used to work, more than $11 billion to bring back some rocks from Mars. Meanwhile, the big rocket that NASA has been building called the SLS, it's supposed to stand for the Space Launch System. It actually, most people call it the Senate Launch System. You can't really tell how much NASA has spent on it, but we estimate that it's been close to $100 billion under development for 10 years. It's had one launch. So the reason space was so expensive is because people were willing to pay others to do it, and those others were willing to take all their money to get it done. Now here's the progress during the 10 years where NASA spent $100 billion roughly on SLS. Here's the progress that Space Force has made on its Starship. Now that rocket on the right that's being caught by Mechzilla, the biggest robotic arm in history, is twice as big as the Saturn V that carried astronauts to the moon. And they're building a factory to make thousands of those rockets, not just the dozen or so that NASA made of Saturn V's. Thousands of them to be able to launch into space multiple times a day. That gives you the magnitude of the change that we're looking at. For about $10 billion for the full development of the Starship, SpaceX is developing the biggest and most sophisticated flying. By the way, the Starship is the biggest flying vehicle that's ever been made, and it flies into space. And it comes back and is caught by robotic arms. By comparison, they're building a high-speed rail between two cities that don't need transportation services in California, and the projection is $100 billion, and no one thinks they can do it for that. So, the cost of a piece of space hardware built by the military-industrial complex, the traditional defense contractors, and NASA, for doing things like roving around on Mars or going to an outer planet, has gotten to the point where a kilogram, which is about maybe a little bit more than the mass of this laptop, of that spacecraft cost $1 million to build. Every one of those Starlink satellites, the estimates in the industry are that SpaceX costs for putting those up are about as much as an expensive car. And the equivalent satellite, if built by the traditional contractors, would be $200 million. So that's an exciting development. So what we see is that space, instead of being the province of extremely expensive billion-dollar programs, becomes the province of affordable programs, moving fast, and providing so the global communications network is moving into space. And then there'll be tens of thousands of satellites up there. And the next wave is to put cameras and radars to have them looking down so that your Google Maps will be real time. So you can go on your phone and see if there's a car in your parking lot when you're not there. And the business implications of that are profound. And then data processing will go into space. Data processing is one of the biggest industries in the world. What drives the cost of data processing is power, and it's getting to the point where power generation in space is going to be cheaper than power generation on the Earth, so data processing will move into space. Once data processing moves into space, it will actually be cost effective to put solar panels are a marginal proposition here on the Earth because of weather, day-night cycles, seasons, all that sort of thing. But a solar panel in space typically puts out 10 times as much energy per year as it does on the ground. Now that makes sense financially. When that happens, we'll be beaming that power down to the ground with microwave beams or lasers, and that will be a truly clean, cost-effective power solution. So, how space is changing now is we're replacing the military-industrial complex with innovative entrepreneurs. Costs are driving by a factor of 1,000, and that's creating massive new industries in space. And it's projected just on the basis of that space is going to go from a few $100 billion a year to trillions of years over the next decade. That's not counting the resources of the solar system. There's a very important law that was passed about 10 years ago called the U.S. Commercial Space Launch Competitiveness Act. That, for the first time, guarantees property rights for American entrepreneurs in space. That's a big deal. Another really exciting thing, brought in by someone who won an election recently, is the Artemis Accords. The Artemis Accords are an international agreement now signed by nearly 50 countries that guarantee that entrepreneurs can benefit from space if they do it responsibly. Extremely exciting development. Space, this is the asteroids. They have everything that you could need to build industries and worlds in space. There's enough material in the asteroids to build worlds in an Earth-like environment that your grandchildren can live in, to build worlds with 1,000 times the carrying capacity of the Earth. That's 1,000 years of exponential human development. So tell your grandkids to go out and have babies, because we're going to need them. The first thing that we'll be harvesting from asteroids is water. It's simple to get water out of an asteroid. You just heat it. It's not the main belt of asteroids that we're going to. We're going to the near-Earth objects, the NEO zone. And Transastra has been studying this for a long time. There are about 1 billion near-Earth objects, but so far humanity has only discovered about 30,000 of them. And it's a limitless resource for space. We have patented the approaches required to go out and harness those materials to be able to build worlds for the future in space. Automated factories will turn asteroids into worlds. At any one time, there's a 10-meter asteroid floating through Earth-Moon space. And at any one time, there are 10 small asteroids that have actually been temporarily captured into orbit around the Earth. This is a fancy engineering diagram that says, actually, they're the easiest things to get to in space for rocket propellant. What about the moon? The moon is our nearest neighbor in space. It only takes about 3 to 7 days to get there, depending on what kind of rocket you're on. And the key there is water. It's clear that the world is going to the moon. We'll be building outposts on the moon. We'll be harvesting the water, oxygen, aluminum, and silicon to make the solar power satellites that I was talking about from the moon. We'll get the power on the moon in the North and South Pole from an invention that Transastra has called the power tower, where you can get perpetual sunlight. So the new space market landscape, there's massive new industries launching things into space. It's becoming cheap enough for people to fly into space. You know, you may have seen that the 92-year-old William Shatner flew into space, so Captain Kirk is real. That was on a very short mission, but we're talking orbital tourism. And orbital tourism, based on the cost reductions that we're talking about, will be such that anyone who's got a decent 401k can put 20% of their 401k into space and go spend a couple of weeks in a space station. Show of hands, how many people would like to do that? Okay. Now Transastra, my company, is a new space venture. As the introductory speaker noted, we've raised about $10 million. What you see here in this picture is me and some of my engineers, and probably someone that, the fellow with the Hawaiian shirt next to me in this picture is a guy named Matt Bellamy. He's the front man for the rock band Muse. He's actually one of the investors in our company. What you see behind them is a capture bag. This one happens to be transparent. We're developing capture bags for capturing asteroids and cleaning up orbital debris in space. In order to mine asteroids, you need to do 4 things. You have to detect, capture, process, and move. Detect means better telescopes. Capture means capture the asteroids in bags. Material processing technology, and movement. We've got about 20 total patents pending in all those areas. And about 14 issued as of recently. Most of the work that we do to make money is for the Space Force these days. So what we're doing is we have a vision for asteroid mining. We've solved the technical problem of how to do it on paper. We're turning those solutions into reality by building businesses in the here and now to help NASA and the Space Force get their job done more cost effectively. The first business is called space domain awareness. This is the ability, with those hundreds of thousands of satellites that are up there, the Space Force has a critical need to know where they are and what they're doing. We've invented unique telescope technology using special software that allows us to see a spacecraft about the size of this podium 300,000 kilometers out into space, so further than the moon is from the Earth. We recently saw a Chinese satellite out there have a sub-satellite separated from it, and no one else saw that. And so so we're using our Sutter telescopes that are named after Sutter's Mill in California, where gold was invented, to prospect asteroids, but we're taking contracts from the Space Force to find things in space to help with national defense today. So right now, we have a global network. The green dots represent we have 4 telescopes in California, 4 in Arizona, and 6 in Australia. And we're building out a global telescope network. You can see the video of one of our telescopes working. That's one with 6 telescopes. We're building out a global network so that we can really monitor what's going on in the night sky every night for finding asteroids and for helping NASA and the Space Force get their job done. That's what our turnkey observatory looks like, and we're starting to deliver those into the field this Christmas. Last year, Time Magazine gave us an award for Invention of the Year for our Flytrap orbital capture bag, invented to capture asteroids for asteroid mining, but very useful for cleaning up orbital debris, because when these satellites, these thousands of satellites collide with each other, it's very dangerous. If there are satellites that are out of control, they need to be cleaned up, and they're important defense applications. Our definition of orbital debris is any piece of human-made hardware that's not where our customer wants it to be. And that's all I'll say about that. So our essential services are orbital debris removal and then using our asteroid mining technology for recycling. This is a picture of the space station. I'm announcing here for the first time that we've just been awarded a contract by NASA and its partners to fly our capture bag on the space station in 2025 to demonstrate this technology so that we can use it for Space Force, NASA, and other customers to help clean up orbital debris. So asteroid mining is the stepping stone to the solar system. After that, we'll be building factories in space to extract those resources, and then using AI and robotics, building first satellites that work in space, and later bringing service, actually building product in space, building factories in space, and returning those products to the Earth. So for humanity to continue to thrive on the surface of the Earth, where we have a biosphere that we need to take care of, and it's a real problem, we need to move manufacturing into space where there's no biosphere to take care of, and use the limitless resources of the solar system to make that happen. So Solar Forge is the ultimate orbital foundry, and it's something that we're doing the early work on today. So at TransAstra, we like to say, let's go further together. I hope that gives you an idea of what's happening in space, and there'll be time for Q&A. But before then, there's a little video that I'd like to show you that a student from USC made about our company. Venture-funded startup company with contracts from NASA and the Space Force that is developing the technologies and systems to help humanity move into space. There's enough material in the solar system to build worlds in space to support a population of humans of up to 1 trillion people. And that's an unlimited future, and we are positive about that. And the way to make that an unlimited potential for our species is to learn to harvest the resources of the solar system. Hi, I'm Joel Sercel. I'm the founder and CEO of TransAstra. This is the Hive. This is our headquarters at TransAstra. So the engineers work in the office area. Through that window, you can see the laboratory area. That's where we have our 2 large vacuum tanks, our large light sources, which are solar simulators that simulate how the sunlight behaves in space. We have our fabrication facilities, our machine shop, a rapid prototyping lab, and we do the development of all our different hardware projects out in the lab. Homo sapiens are consummate survivors. We have wanderlust, we have curiosity, we grow, we expand, and now we cover the whole planet. And at each point, as our ancestors spread from one domain to another, they developed the technology to handle that new domain, from dugout canoes to sailboats to steam engines, and that allowed us to spread throughout the globe. And now we've kind of mastered the Earth, and there's nowhere else to go but up.
We are in the beginning of a mass extinction, and all you can talk about is money and fairy tales of eternal economic growth. How dare you!
Always take always take policy advice from children.
That, the human race is on the edge of extinction, coming to an end. Last I checked, there were about 8 billion of us on the planet. And if you study history and you really look at what's happened over the last 100,000 years, in virtually any epoch in that 100,000 years, it's been better for people than it has been in the previous epoch. The fraction of people who live in wealth is the highest it's ever been. The fraction of people who live in poverty is the lowest it's ever been. Lifespan is the longest it's ever been. Access to clean water, clean food, shelter, and medicine is greater for a larger percent of the population than it's ever been. So the doomers who are looking at the current situation and projecting the demise of humanity are just not thinking clearly.
That's the
So there's
starship
an
I told you about.
in our need to go into space, because every year that we don't see that opportunity and harness that opportunity is another year of young people being told about the gloom and doom of the future. People talking about the extinction of the species, and they have this word sustainable. And instead of sustainable meaning smarter, more efficient, using technology to solve problems, sustainable means do less, don't have children, don't strive for the future. And that's not good. So real sustainability comes from technological innovation, finding new resources, and being smarter about how you attack problems.
These pictures were taken in part due to the excellent estimates of exposure times by Carolyn Porco. That's home. That's where we are. On it, everybody you love, everybody you know, everybody you've ever heard of, lived out their days there. The aggregate of all our joy and suffering, thousands of confident ideologies, religions, economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilizations, every saint and sinner in the history of our species lived there. This picture underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. Thank you.
When I was a young man, Carl Sagan was a prodigious writer of really interesting books on science and the universe. And I had been a huge fan of his. And then I worked at JPL, and lo and behold, during my tenure at JPL, Carl Sagan came back to JPL and became a distinguished visiting scientist with his office just down the hall from me. And so it was a real thrill to meet him. And it was a wonderful experience. I learned a lot, worked with a whole bunch of very talented people. But it kind of became clear to me after a while that JPL was an organization that used a lot of government money to do really interesting and exciting things in space, but it wasn't becoming more cost effective, and it wasn't leading humanity to space in a sustainable way. So I wanted to get away from JPL and move into more of the private sector to try to help launch humanity into space. So I left JPL, started a laboratory at Caltech, had a wonderful experience there, but I was really kind of disappointed where the space program was going. I was doing consulting for Fortune 500 companies and for the Department of Defense and NASA and different people, just making a living, kind of enjoying my life. But I got this really interesting consulting gig to evaluate SpaceX's engineering processes and equipment, and it became very clear to me that it was gonna work. The dream of space industrialization is gonna happen. Low-cost access to space is going to make exciting things happen in space. What can I do to contribute to this? And I realized that we've known for decades that the greatest resource in the solar system for humanity's future is the asteroids. There's enough material in the asteroids to build worlds in space with 1,000 times the carrying capacity of the Earth. I was very excited about the prospect of the next big opportunity for humanity to go into space. And if we can learn to harness those resources, move manufacturing and other heavy industries into space, it can reduce stress on the biosphere, it can let people move into space, and we can go back to exponential growth and optimism for the future. So TransAstra is not the first company that's tried to develop the technology and systems to mine asteroids. Big revolutions in technology always involve false starts. You know, for example, before the iPhone, about every 2 years, Bill Gates at Microsoft would get up and make a big announcement about a convergence device that you could carry in your pocket and would have computing and everything you need, and it would be bigger than computers. And he was right, it was going to happen, but it never happened on his timeline. iPhone happened when the technology was right and the right innovator, Steve Jobs, put all the pieces together. So the people who started companies before TransAstra that were focused on asteroid mining were right. They were just a little too early. They started off with plans to go mine asteroids using the sort of launch vehicles and spacecraft of the time, and it just didn't work economically because it was still too expensive to get into space, too expensive to get around in space. There wasn't enough of a market to actually take the propellant that you'd harvest from asteroids and use it in space. And the economics of harnessing precious metals just don't work in the year 2015. So let me talk about the 4 technologies. First, we have our Sutter telescope technology. With that, we find and characterize the asteroids, figure out which ones we want to go harness resources from. Then we take our asteroid mining honeybee vehicles, which are equipped with our omnivore propulsion system, carry the mining vehicle to the asteroid. Once we get to the asteroid, we capture it using our capture bag technology so that we can contain all the resources, make sure it doesn't come apart and float off into space. And then we use our material processing technology to process that material to create valuable products that we then bring back to Earth orbit to sell. The first missions will bring back upwards of 100 tons of volatile materials like water and other valuable chemicals. That's worth about $1 billion each. Later, we'll bring back thousands of tons of volatile propellants, multi-billion-dollar missions, and then after that, we'll be bringing back precious metals and strategic materials. So we view this as a multi-trillion-dollar market eventually. What are we working on today? We have active multi-million-dollar contracts in our telescope technology and our capture bag technology. We're expecting new contracts associated with our propulsion technology. And when we put that all together with past work we've done on materials processing with our processing technology, we think it's at least a few years until we'll be able to do full-scale asteroid mining. We don't make projections of when asteroid mining is going to happen, but it could be as few as a few years or as much as several. The adventure of settling space and making humanity what I call an exoplanetary species started over 100 years ago with a school teacher in Russia named Tsiolkovsky, who worked out the mathematics of space exploration. And he was the first one to talk about going to asteroids and harnessing their resources. Then there have been other pioneers like Oberth and Goddard, Neil Armstrong, the people of Apollo. Now we have a new generation of entrepreneurs that are building companies and creating wealth and making the world better by using space in fundamentally new ways. So it's a multi-generational history, but the adventure is just getting started. And so my children and their children, your children, each generation will have it better, and we'll be pursuing this incredible adventure of humanity's journey into space. I can see a future of at least 1,000 years of growing throughout the solar system. After that is the launch into interstellar space and the spread of this wonderful germ of biology that we only know that exists in one place in the universe. As Carl Sagan said, we are the way for the universe to know itself. Without us, the universe is darkness without knowledge or awareness. So my call to action for young people is to believe in a positive future. And on the basis of that, get to work. Get to work on the adventure of building a future for humanity. Yes, it's science, technology, engineering, it's STEM, but it's also the arts, it's communication. The adventure of space exploration and settlement requires everybody to pull together to make it happen.
So that's my mission. Thank you very much. So we left some time for Q&A. Yes, sir.
Thank you very much. I've been following Catherine Austin Fitz for about 10 years, and she spoke yesterday. She and a number of people have been talking about how that missing money might be being used to build out to space. Tomorrow there's going to be a UAP hearing in Congress where they'll probably be talking about sequestered technology. And living in Ann Arbor for 40 years, let's just say I've met a few people in black projects who might agree with something like this. What do you think might happen tomorrow when it comes to trying to bring some technology out that's been sequestered that would make your job much easier?
I think claims of exotic sequestered technology are overblown. I think I think that there are too many ethical people in the government to keep secrets that shouldn't be kept. There was a gentleman that I used to work with at NASA headquarters. His name was Dr. Gary Bennett. He was an expert on nuclear rockets and nuclear propulsion. And there was a classified program called Timberwind. By the way, you can read all about this in the New York Times if you go back. And they were doing some really cool work with nuclear rockets. And he felt as though it was unsafe. So he released it to the press and went to jail on the basis of his ethical predilections. The United States is incredibly bad at keeping secrets. Recently, the Chinese showed their J-35 fighter jet. It looks just like the F-35. There's a reason for that. They stole all of the technical files of the F-35 off of the classified internet, every one of them. We don't keep secrets. We're bad at it. We're really good at being free and open. By the way, so that's just my view. That there are no aliens that we know of. And if they didn't want us to know about them, we wouldn't know about them.
Thank you so much.
By the way, I think the whole UFO thing is a Chinese psyop to get people to talk about our classified programs.
Thank you so much for your time today, Dr. Sercel. I was wondering if you guys at Transastra think further lunar development, such as processing lunar regolith to build factories on the moon, as well as in orbit, or even creating launch pads on the moon to further reduce launch costs, are feasible or better than orbital development?
They're feasible, and they're better than orbital development for some stuff, but not for others. So the resources that are available from the asteroids are fundamentally different than the resources that are available on the moon. The moon has water, oxygen, aluminum, silicon in large numbers, in large quantities. So there's lots of stuff you can do with lunar resources. Not only that, but the moon is a nearby body that's always there a few days away. So we will build outposts on the moon, and Transastra has collaborated with Jeff Bezos and Blue Origin on lunar outposts in the past, and we hope to do that more again in the future. I've known Jeff since 1999. That's all good, but it's not the answer. And the moon is a stepping stone, but it's a big step. The big problem with the moon is, like all other planets, it sucks. It has gravity. And that means it takes a lot of rocket propellant to get to and from it. Whereas the asteroids, wherever you go in the solar system, there's asteroids, and they have things that aren't on the moon, large quantities of iron, nickel, platinum group metals, carbon. Practically the entire periodic table is there. And so the asteroids will be the refueling stations on the way to anywhere. There, as I've repeated a few times, there's enough material in the asteroids to build worlds that people can live in with 1,000 times the carrying capacity of the Earth. There is enough. You can't build a single place on the moon that we know people can live in, because we don't know if people can live in reduced gravity, whereas we can make artificial worlds in space that do. So the real answer is the free market will decide what the right optimal mix is. People aren't smart enough to figure that stuff out. Entrepreneurs think they know the answer, and I'm one, and so it's going to be asteroids. No, it's also going to be the moon. We did a study that if you harvest propellant from the asteroids and use that for your spacecraft going back to and from the moon, we can get it down to the point where something like 50,000 people on the Earth have enough money to pay for a 2-week vacation on the moon. So it may be that asteroid propellant is the key to Jeff building his hotel on the moon.
being a member of this rather new private industry, how do you feel about the regulatory framework that currently exists? Do you think it hampers innovation as is, or do you think it's right now pretty fair and equitable?
There are some good things about it, and so the question is about the regulatory framework in space. There are some good things about it, and there's some bad things about it. There's some real challenges with international law. The first challenge with international law is that if a nation flies something up into space and just leaves it as derelict hardware, if another nation goes and touches that for salvage, it's an act of war. That has to change. There are no salvage laws in space. As a result of the fact that there are no salvage laws in space, orbital debris is growing exponentially in space. Now you might think, there's only, by the way, there are a few million particles of orbital debris in low Earth orbit, and there are tens of thousands of pieces that are big enough that you can kind of see, or like a nut or a bolt. You think, well, the Earth is really big. There's only tens of thousands of these pieces, or even millions. How could that possibly be dangerous? They're really far away. Let me explain. So my father was a jet fighter pilot. And I remember one day I came home from school and I said, it's like, hey son, how was school today? Good. I told him, I didn't like math or whatever it was. Actually, it was spelling for me. How was your day? And he told me this interesting story. So he was in the F-100. He was the base test pilot. And his job was to take the airplane up, go to supersonic speed, take it up to Mach 1 with full afterburner. And he's flying this airplane, putting it through its test program. And he sees a dot on the horizon. And then the next thing he knows, he sees an airplane flash by, and it's just the windshield of a B-52 with the pilot reading a newspaper. And in the time that it took for these two airplanes closing up, his airplane just above Mach 1, the other one just below Mach 1, it went from a dot to a newspaper, okay? That's at Mach 1 closure speeds. Orbital speeds are Mach 25, so Mach 50 closure speeds. So the point is that every particle goes really far every day. So the speeds are so much higher than you can possibly imagine without technical analysis to see how many opportunities are there to collide with other things. And once you see it, it's too late. So here's a little known fact about the space environment. The most dangerous thing that an American astronaut has to deal with in low Earth orbit is orbital debris. It's the biggest danger to astronauts. I had a collaboration with a space shuttle astronaut once who talked about, he was up on the space shuttle, and all of a sudden they heard a big whack. And they were like, something hit the ship, what is it? And they looked around, and one of the windows were about this big, they're about that thick, and buried halfway into that window was a tiny fleck of titanium paint. Had it been 5 times bigger, it would have blown the window out and everyone would have died. We've got to deal with the orbital debris regime, and that's one of the things that Transastra is really focused on. The asteroids are the orbital debris left over by the solar system. We have designed capture bags for cleaning up that orbital debris and turning it into useful materials. We intend to use our capture bags to clean up orbital debris and recycle it, but the regulatory regime is not favorable to businesses doing that. So that's one example. If you go to my LinkedIn profile, you can read an essay that I wrote in collaboration with General Steve Quast. Steve Quast was basically the architect of the Space Force, and I was lucky enough to get to work with him a little bit back in the 2015, 2014 timeframe on that. He and I wrote an essay called To Boldly Go Responsibly. We have to be bold. We can't over-regulate, but we need enough regulation to do it intelligently so we don't create. Every time humanity goes into a new domain, it screws up royally because it's always thinking about regulations from the last domain. But technology is getting so much faster and more powerful that we have to think ahead instead of in the rearview mirror. So the downside here is people who take their directions from that young lady in the video will want to regulate everything and prevent it all from happening. And there are some people, there are not humanists, they view humanity as a blight on the universe, who do not want us to go. And they'll do everything they can from a regulatory perspective to stop it. So what we need to do is minimum but effective regulation that create a playing field where the bold, the hardworking, and the talented can make things happen for the betterment of us all. That's what free markets are all about. But free markets require regulation to work properly.
Speaking of space debris, you mentioned this growing shell of satellites being built out into space. And at least the figure had them going in all sorts of disorderly ways.
It only seems disorderly because you don't know the order. It's very orderly.
All right, well, I'm just wondering, is there a way of creating, I take it there's a way of creating a pathway through that so that if you want a rocket ship to go through them, you don't get hit by all this clutter?
Well, what we count on mostly is that space is big, although low Earth orbit is the smallest area in space in some ways. And so you're counting on luck to not hit the debris to a large extent. However, it used to be up to NORAD, and now it's switching to the Department of Commerce to keep track of all the objects in space, and they keep track of tens of thousands of objects. And then there are private companies that ingest all that data, and then they send warnings to different satellite operators. And satellite operators have to often maneuver to avoid orbital debris and collisions with other things. Now, the satellite operator that has maneuvered the most to prevent its satellites from colliding is SpaceX. SpaceX, in the last few years, has become by far the most experienced organization in space in history, 10 times more experienced than anyone else. Because they've launched hundreds of rockets, more than anyone else, and thousands of spacecraft, more than anyone else. And so what you're talking about is the field of space domain awareness and traffic monitoring and regulation. It's a whole field of endeavor. Transastra works on the edge of that because our telescopes are designed to see, navigational hazards in deep space. So we have some awareness of it, but that's a whole field. And so if you're a satellite operator, you're getting pinged all the time on the internet saying you better maneuver, you better maneuver. I think SpaceX has maneuvered their satellites, it's at least thousands of times, and it might be tens of thousands of times. By the way they normally maneuver their satellites is the Starlink satellites, they look like this. They have a big solar array and then a deck. And the solar array is all their area. And the rule is you have to reduce your probability of collision down to some level. Normally that just means they fold their solar array down temporarily and then fold it back up. It's kind of clever. Everything they do is kind of clever. We respect them and we try to learn from them, learn from the best.
2 questions. Have you met with Elon and had in-depth conversation with him about his vision?
Yes.
Secondly, where do you think China is in your industry?
China is an existential threat to freedom and democracy. And the only way we can defeat them is with entrepreneurial spirit and Yankee ingenuity. So we have to get off the backs of real companies and stop letting the military-industrial establishment suck the life out of technology in America. I've spent hours with Jeff Bezos and about an hour and a half in a one-on-one conversation with Elon Musk. They're both brilliant. They're both amazing people. Elon Musk is, I taught at Caltech for 12 years. I did my PhD there. I knew Nobel Prize winners. I worked with the National Academy of Sciences. Carl Sagan. By the way, Carl Sagan, most underrated scientist of the 20th century. All the scientists were jealous of him because he could actually speak and he was popular. But he was like scary brilliant to actually talk to and engage with. The only person that I've ever spoken to Freeman Dyson, who was, at the Institute of Advanced Studies, who was, kind of where Einstein was. He's a mentor of mine since I was in high school, right? So I've spent some time with some bright people. Elon is like an alien. He's so much smarter. So, on the internet, there's a meme that Elon is an alien stranded on our planet, developing the technology to get home. He doesn't deny it. Just think about what he did in the last month. He hacked how to get someone elected. And he just came in, dominated the industry, and just focused on it and did a better job than anyone else has.
Time for one more question.
I'm sorry my answers are so long-winded, but I'll stick around to answer any other questions.
In addition to space debris, are there any other unintended consequences that have arisen? And then how do you and other innovators maybe anticipate drawbacks to your vision?
Well, there are always unanticipated consequences. So let me make a list of 20 or 30 of them for you. One that I really worry about is a bioethics concern about Mars. And that is, as far as we know, we're the only life in the universe. People think there's life on Mars. What is the nature of that life on Mars? One thing that I worry about with Elon wants to build a city on Mars. Now, he's building these rockets. Now, you think it was really cool in Apollo that they built this capsule that could take 3 guys to the moon and back, right? That Starship is designed to carry 100 people to Mars for about $500,000 a head, which means that lots of people can take part of their retirement savings and go retire on Mars. Building massive cities on Mars is very interesting, but the bioethical considerations of potentially interfering with an ecosystem that we've never touched really need to be thought about carefully. And some of the advocates of this come across as a little cavalier to me. And there are dozens of others. Okay.
Thanking Dr. Sercel.